In this video, we'll have a look at how we express large numbers in a form called scientific notation. Let's first of all consider a light year, which is a measure of distance. 1 light year is equal to 9,460,000,000,000,000 meters. Let's have a look and see what that number actually looks like. So we start with a 9, and then it's 460, followed by 12 more zeros. And in scientific notation, we express that as 9.46 times 10 to the power 15 meters. In this video, we'll have a look at how we make the change from the number in everyday form to one in scientific notation. Let's first of all look at a number which is 1 quadrillion. We can see here we've got 1 followed by 15 zeros. Now let's break it down into powers of 10 so we get an understanding of actually what this number represents. 10 to the power 1 is just 10. 10 to the power 2 is 2 tens being multiplied together, and 10 multiplied by 10 is 100. 10 to the power 3 is 3 tens being multiplied together, 10 multiplied by 10 multiplied by 10, which gives 1,000. Now each time we increase the power, we should notice that the number of zeros in our answer matches the index. In this case, we've got 3 zeros in the answer, which is 1,000, and the index is 3. So going back to our original number, which is 1 quadrillion, we can notice that we've got a 1 followed by 15 zeros. That means that that can be represented by 10 to the power 15. Now, of course, not all numbers have a 1 at the start followed by lots of zeros. So how do we represent other large numbers? Well, we know if we change that number from 1 quadrillion to 2 quadrillion, what we can then say is it's 2 lots of 10 to the 15. And we can write that, as we see down below here, as 2 times 10 to the 15. So what we'll do is we'll take this idea further so we can represent any number using scientific notation. Let's consider the number 2 quadrillion and 23 trillion. The first step is to use exactly the same digits, but to express the number as 1 from 1 up to but not including 10. So in this case, we take exactly the same digits and we make the number 2.023. We then go back to our original number, and we can see that there are 15 places or 15 digits which follow the initial value of 2. This means that we have to multiply 2.023 by 10 15 times to ensure that we get back to our original number of 2 quadrillion and 23 trillion. Now let's go back to our original example, which was the distance represented by 1 light year. To put this into scientific notation, the first thing we do is keep exactly the same digits, but we express it as a number from 1 to 10. In this case, it will become 9.46. The next thing we do is to look at the places which follow the value of 9, and there are 15 places. That means that we need to multiply 9.46 by 10 15 times to get back to our original number. So we express that as 9.46 times 10 to the 15. Now we'll express some numbers in scientific notation using pen and paper. The first task is to use the exact same digits that we have, but express the number as 1 between 1 and 10. In this case, we can see it's 7.496. We then need to ask ourselves, how many places does the decimal point need to move to get back to the original position? In this case, it's 3, so we multiply by 10 to the power 3. In the next example, we express the number as 3.82. The decimal point has to move 9 places to get back to the original number. So we write multiplied by 10 to the power 9. So here are some numbers for you to try. So it's suggested that you pause the video, try to put these numbers into scientific notation, and check to see if you've got the correct answer with the solutions that are about to follow.